Hi there, welcome to my channel mathssl. I'm speaking Thaqib Latif. I'm going to show you analytical geometry question. Now this is exam type question also, exam question. This is a question number 4. The question says in the diagram below A, B, we don't have the vertices points of B, and the E are the points on the Cartesian plane, and the C as well is the midpoint of AB. So this is the information of the sketch. C is the midpoint of AB, and A, B, and E, and F as well. These are the vertices of the quadrilaterals. So A, F, B, E, or you can say A, E, B, F. This is a quadrilateral. So the question says, first question, calculate the length of AE. So the length of AE, we need to find the length. Obviously, we can apply the distance formula. So the length of AE, I apply the distance formula. You can say x1 minus x2, or you can say x2 minus x1 square, same thing. And after I apply the distance formula, this A and E, this is the coordinates of A and E. This is my x1, y1, x2, and y2. So x1 minus x2 minus become positive, or you can switch around. You can say x2 minus x1 square, same thing. So my answer is gonna be a 5 units. 2.2 say calculate the coordinates of B. So the B is here. B is the midpoint of A, B, the midpoint is C. So looking now, he asked the coordinates of B. So we're gonna find the coordinates of B by calculation by midpoints. So the midpoint formula I'm gonna apply here now: x1 plus x2 over 2, y1 plus y2 over 2. So this is A, B, and C. I write the coordinates of A, B, and C. So this is my x1, and the C is the midpoint of AB. This is your x, this is y. So I'm gonna find the missing coordinates of B by midpoints by calculation. So first I find the midpoint of between A and B. So obviously I don't have the coordinates of x and y. So x plus 1 over 2, and I'm gonna equate with 2, because this is the midpoint of AB, x plus 1 over 2. I'm going to equate with x, and the y I'm going to equate with y. So you cross multiply, or you can take the LCD, multiply by 2 both sides, and then I get x plus 1 is equal to 4, and then x, the 4 positive 1 become negative 1 this side, and the x value is 3. And same I did do this one, same thing, y plus 3 over 2, I find the y, and therefore the B is 3 and negative 1. So by midpoint I find the coordinates of B. So you understand, because I am explaining this chapter, analytical geometry, around about plus minus 20 videos. Only I explained the concepts. Now obviously exam type questions, and there shouldn't be a problem, because you should know by now how to solve these type of questions. So the question 2.3 say calculate the length of EB. Now EB is here. EB, the length of EB. We do have the coordinates of B, so we're gonna, through distance formula, we're gonna find the length of EB. So I apply again the distance formula, and this is E and B, coordinates of E and B, and there I find the length of EB, which is also 5. The next question says 2.4, what type of special quadrilateral is AFBE? AFBE. He asking you what type of special quadrilateral is this. So now must remember here. So this side is, they already provide for you and this notch, this dash, this AF is equal to FB, and we already found now that the EB is equal to AE. Why? Because uh, the EB is also 5 units and AE is also 5 units. Therefore, AFB is a kite. Two pairs adjacent sides equal. So must remember this is the reason. Because AF is equal to FB, which they already provide for you, and it is given. And then AE is 5 units, EB is also 5 units. We found through distance formula, so which mean A is equal to EB. So this is a kite because both pair of adjacent sides are equal, so this is a kite. 2.5 says if E, C and F are collinear, calculate the value of K. So which mean he's saying now here that E, C and F, he say if they are collinear points, then you need to calculate the value of K. I'll show you how. So I have E, C and F, and first we need to find the, must remember these 3 points, if they are collinear and their gradients are equal to each other. So I choose any 2 points, and then I'm gonna take the gradient between those points, and then I'm gonna equate to find the missing coordinates of K. Obviously the K must be included because we need to find the missing coordinates of K, and that's the point of F, coordinates of F. Now, so first I take uh, the gradient between CF, y2 minus y1 over x2 minus x1. So this is my x1, y1, x2, y2. I plug into this formula and I get the k negative 1 over 2. This I found after the calculation. And then now I'm gonna do the find the gradient between EC. So you can write this is x1 y1, this is x2 y2, or you can write separately x1 y1 x2 y2. I plug it into this formula again. I find the gradient of EC, which is 1 over 2. Now I'm going to equate these two gradients to find the value of K. So collinear points, which mean MEC must be equal to MCF. Both gradients I'm going to equate, and then MEC I got 1 over 2 and K negative 1 over 2, that is gradient between C and F. Now I'm going to cross multiply, and this become 2, and this become 2K minus 2, and then simplify the K value is 2. Or I can do this way, LCD is 2. So both side I multiply by 2, 2 cancel, and this side also 2 and 2 cancel. We only got K negative 1 is equal to 1, and the K negative 1 become this side positive 1, become 2, so therefore K value is 2. So therefore we got the K value 2, and the F coordinates gonna be 4 and 2. So the 2.6 says if is AF perpendicular to FB, justify your answer. So we need to see if AF is perpendicular to FB. So this is AF perpendicular to FB. So we need to see, right? So we need to find the gradient between these 2 points, and then we can see if they are perpendicular or not. I'll show you how. So I'm gonna take the gradient between AF. So this is my coordinates of A and F. X1 y1 x2 y2. I plug it into this formula. I get the gradient between A and F is negative 1 over 3. Now I'm going to take the gradient between FB. So this is my x1 y1 x2 y2. I plug it into this formula, and the gradient between F and B is 3. Now both gradient I must multiply, and answer must be equal to negative 1. Then if the answer come equal to negative 1, then which mean they are then which mean AF perpendicular to FB, otherwise not. So AF, the gradient between AF I got negative 1 over 3, and FB I got 3, and 3 cancel, negative 1 is equal to negative 1. So the left hand side is equal to right hand side. So the gradient I multiply between these 2 points, I multiply these two gradients, and the answer come negative 1. So which means therefore AF perpendicular to FB. The last question say if ABDF is a parallelogram, determine the coordinates of D. But remember there is no ABDF here. Have a look here. So he's saying now ABD somewhere there F. So you can draw a little sketch, a rough sketch to understand this concept, and then you can find the missing coordinates of D. So I'm gonna I draw a parallelogram ABDF. So I write all the coordinates, and then obviously D coordinates is missing. I need to find the coordinates of D. So I'm gonna do by inspection, rise over run, change in Y over change in X. So the A to F. How you get to F from A? A to F. So A X is 1 and F X is 4. So if you add 3 plus 3 become 4. So which mean from A to F, so if you add, obviously you right hand side and arrow must show right hand side. If you minus, the arrow must shows left hand side. So now you get 4. Now this is change in Y, 3 and 2. So you minus 1 become 2. So which mean the vertical change. So the arrow must show downward. If is you add, the arrow must show upward. So 3 minus 1 become 2. So exactly I'm gonna do same thing here, B to D. So B we got 3 and negative 1, D we don't know. So horizontal change, 3 plus 3 become 6, and now the arrow show downward, so which means I must minus 1, minus 1 and minus 1 become minus 2. So the coordinates of D is 6 and negative 2 I found through inspection. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.